Hello and welcome to Penn State Berks. Here, Dr. Rungun Nathan has tasked a small group of engineering students to design and prototype a microfluidic bandage aimed at optimizing the healing of various types of wounds. In this group are Ryan Bingaman, Ryan Fideli, Logan Crick, and Michael Schittler. Our goals for this project are as follows. First, our main goal is to design a customizable bandage for various types of wounds, including lesions, lacerations, and abrasions. The bandage should also be able to cycle saline and air over the wound at different intervals to optimize the healing process. It should also be easy to put on and operate, and the final objective is to minimize waste over traditional bandages by making the bandage recyclable, reusable, and able to be cleaned easily. In this unfortunate event, a man has pretended to accidentally brush his arm up against a grinding wheel while at work. Typically, his abrasion would need to be cleaned with a saltwater solution and dressed in gauze.
Don't use the gauze, sir. I have a microfluidic bandage. This will heal your wound much better.
Luckily, with our microfluidic bandage, all you need to do is take measurements of the wound using our measuring frame and then use them to draw a tailored design using CAD tools. Using 3D printing technology, a microfluidic bandage tailored to the patient can be made in a couple of hours. All that's left is to fix the flexible bandage to the area of the patient's wound using a wrap. Then a saline solution is injected to keep the wound clean by flushing out bacteria and debris. Each bandage design has an inlet and an outlet port so that the injected saline and air can both move freely throughout the channels over the wound. When injected, the bandage carries the saline through multiple channels in order to clean across the entire wound. Since each bandage is custom made, a variety of shapes and sizes can be used for various types and locations on the body. Through testing and many design iterations, we were able to accomplish many of the goals that we set in the beginning. Most importantly, we accomplished our main goal of designing a bandage that is customizable. This is the most critical step because every wound is different and we wanted the bandage to be able to be applied to most parts of the body. Also, since the bandage is printed with thermoplastic polyurethane, it is biocompatible and recyclable. It can also be cleaned and reused. The most prominent shortcoming stems from the manufacturing method. While injecting the saline, the fluid leaks into the actual structure of the bandage due to microscopic gaps between layers in the print. Also, depending on the part of the body, the bandage may require that another person apply it. Although the bandage is made out of a flexible thermoplastic, it may still be too rigid for certain locations on the body as well. Moving forward with the project, there are a few fixes that can be made. To combat the leaking issue, different materials or 3D printers could be explored. It's possible a flexible resin coating could solve the issue too by patching holes in the structure. Otherwise, an alternate manufacturing method may be sought. The flexibility issue can be fixed by altering the geometry of the structure to allow more bending. Otherwise, another less rigid material may help. With these fixes, we feel that our project will be able to be taken to market to improve the convenience and healing time for consumers.